Hi everyone, hope you all had a good Thanksgiving and stayed safe this weekend. We're going to look today at derivative rules for exponential functions. So we'll do some examples in this video, and when you come into class on Monday, we'll drill a little bit more, and we'll go over the rules for logarithms, which is the other derivative rule on this set of notes. We'll do that in class on Monday. So that's our plan for going through these notes. So starting with talking about exponential functions. In exponential functions, the derivative of the exponential function is actually just the same function times our natural log of whatever the base is. And so, for example, if we're looking at 2, the derivative of 2 to the x is just that same function, 2 to the x, times the natural log of the base. So the natural log of 2. And same for, say, 5 to the x. Derivative of 5 to the x is 5 to the x times the natural log of 5. Now there's a special case when we have e to the x. So the derivative of e to the x is e to the x times the natural log of the base. Well, the base is just e. And if you remember your logarithms, natural log is a base of e. So the natural log of e is just 1 because it asks the question, e to what power equals e? Well, that's 1. So the derivative of e to the x is just e to the x. And this is actually what makes e to the x special. That's a part of the reason that we're interested in e, is because the derivative of that exponential function is itself. And finally, of course, this du dx here is making sure we don't forget the chain rule and multiply by the derivative of the inside part. So if we've got a function up in the exponent, we need to make sure we have that chain rule and multiply by derivative of the inside part. Let's look at a couple of examples. Again, we won't do all these because we'll do some of them in class, but I will do a couple of these so that you get a sense of what we're doing. Y prime. Derivative of 2e to the x, well, that's going to be 2 times the derivative of e to the x. Well, derivative of e to the x is just e to the x. Done. There's our answer. Over on b, our derivative here, derivative of e to the negative x is just e to the negative x. Times derivative of the inside part. This is where we have our chain rule. Derivative of negative x, we need to take the derivative of what's over the exponent. That's negative 1x, so its derivative is just negative 1. So our answer is going to be negative e to the negative x. Jumping down to part E, I'll ask you to do part C and D in class. Derivative of e to the square root of x is e to the square root of x. But then we got to multiply by our derivative of the inside part. Derivative of square root of x, that's x to the 1/2. So we want 1/2 x to the negative 1/2. So 1 over x to the negative 1/2 means take square root and put it in the bottom. So another way we can rewrite that is e to the square root of x on top. And then we have a 2 square root of x on the bottom. So these derivative rules are actually pretty straightforward in comparison to what we were doing with our inverse trig, especially with e to the x. Now let's look at some exponentials. The only difference with exponentials, remember, is that we still have the derivative being itself, but then we need to multiply by the natural log of the base. And then, of course, we need to make sure we have the chain rule. So our first one is x to the e. Now be careful, because this is not an exponential. Exponential means there's a variable up in the exponent. There's not a variable in the exponent here. This is just a power rule. So that means we're going to take the e, bring it down out in front, and then we're going to have x to Subtract 1 from the exponent. So we have e minus 1. And that's our answer. So don't confuse the power rule for the exponential rule. Power rule is if variables in the base and we have a number in the exponent. Exponential functions have a variable in the exponent and a number in the base. So C is our kind of basic rule for exponentials. So let's look at part D. In part D, we have 3 to the cosecant of x. So our derivative of 3 to the cosecant of x is 3 to the cosecant of x times the natural log of the base. So our natural log of the base is going to be 3. Then here's where we get our chain rule. Times derivative of the inside part. Derivative of cosecant of x is negative cosecant of x cotangent of x. And then we can rewrite and rearrange this around, but that is our final answer. So in exponentials, you just rewrite that function times natural log of the base, and then make sure you got your chain rule. That's the idea behind these. All right, that's all I want to look at for now. We'll go through the rest of them on Monday, so I'll talk to you then.